Very quickly, here's the engineering and software and IoT prototype as it stands. So it may not look like much, but this is the kind of exoskeleton for the trash can. They have the base, and then we have these rails here. There'll be another pair of rails here. What I want to talk about is do a little bit of introduction to the sensor network that we have here, starting from probably the more difficult one, which is down here. So this is a load cell, and so this will measure weight. You might find something like this in an industrial scale. This particular load cell could measure up to 10 kilograms. We'll probably replace it with a 50 kilogram one just to make sure that we can measure really heavy stuff. Again, these are things that are in your bathroom scale or industrial scales. So this load cell connects to an amplifier here. This amplifier then outputs a voltage, amplified voltage to the microcontroller. The next piece we have is we felt like it would be important to be able to measure how full trash cans were. So we have an infrared distance sensor mounted here that's able to tell us how full or empty the trash can happens to be. And the last thing we integrated this week was a proximity sensor here, another infrared proximity sensor. This can sense when you throw trash in. So we also wanted to see how much were these particular trash cans being used. So this use case is kind of for a city. So show you kind of the really, really cool part of this beyond the sensor networks is this is now integrated into a back-end system that sends what we call telemetry data to the web, to a dashboard. So we built this dashboard here. At the top we have a map. This is 10-cent maps. So we can map where every trash can is. So you can think of hundreds of trash cans around a city or even in an office building. On the left here we have the amount of trash, and you can see this is a time series graph. We thought having a time series graph would be interesting because, again, we could take something like use some machine learning and algorithms to figure out, based on the location of the trash cans, how full they were, figure out an optimal route such that you could say, well, this trash can appears to get full at this particular time. So kind of fun. I'm going to put my hand underneath to simulate a full trash can, and you can look here very quickly, within about 10 milliseconds or so, that responds, and I'll take it away, and the trash can is empty. Put my hand here, the trash can is about half full. Next, we are measuring weight. And so this scale, in fact, this whole sensor network probably equates to maybe $5 US. So to outfit a trash can with this type of a system would quite literally cost you probably less than $5. I think we could bring the cost down to just a few dollars, including the cost of the microcontroller. So here's the fun part, so weight. So I'm putting a little bit of weight on the scale, and you can see the weight, and sorry it's in pounds, I'll convert it next week to kilograms, but I'm putting some weight on this scale here, and I'm going to really press down. You can see this load cell will rapidly go above 10 pounds, so it depends how strong I am. Yeah, about 7 pounds. And lastly, we're tracking how the trash can is used. So when some trash is thrown in, I'll simulate that. Here, you'll notice this graph, again, time series graph. This is going to just spike to 1 or to 0 over time. That might make more sense. So next week we're hoping to do a little more design in terms of the UI and stuff. So that's pretty cool.